All right, IBAISL2. We're doing the last section in Chapter 8, which is all about the t-test. So t-tests are really just another hypothesis test. So we can write that. Another hypothesis test. We've done so many hypothesis tests, with chi-squared and the goodness of fit and a lot of things. We're finding p-values and things like that and comparing them to critical values. Let's go ahead and talk about what a t-test is. A t-test is used when the two data sets are measuring the same thing. So a t-test wouldn't be appropriate if you were comparing caffeine consumption and gender or something like that, because they're two different parameters. But if you're testing two sets of data that are basically the same parameter, you can use a t-test to tell whether or not the two are significantly different. And what I mean by that is that whether or not their means are different. I realize that most means of data sets are actually different. Like one might be 25.2 and the other is 28.3. But the t-test helps you figure out if they're statistically different. How different do they have to be before you're well, they're actually different. So this is only used with normally distributed data. Remember, a normal distribution is like that bell curve. It looks like this. The null hypothesis with a t-test is that the two means of the data sets are equal. They're the same thing. The alternative hypothesis is that the two means are not equal to each other. Remember, we're not saying whether they're actually literally equal or not equal, whether they're statistically equal or statistically not equal. First example, Mr. Arthur gives two chemistry groups the same test. He wants to find out whether there's any difference between the achievement levels of the two groups. So he tested one group and they got these scores, and the other group and they got these scores. The first thing I noticed that these score sets aren't even, that there's more kids in one class than the other. That's totally fine with a t-test. You can do that. Null and alternative hypothesis. In very simple mathematical terms, the null hypothesis with the t-test is that the mean of data set 1 is the same as mean of the data set 2. Another way to say this in English is there is no difference between the grades of group 1 and 2. The alternative hypothesis is, of course, that the means do not equal each other. Not like that. So in English, this is there is a difference. Excuse me. So there's our null and alternative hypothesis. Part B says find the t-value and p-value for a t-test at the 5% significance level. So the way you're going to do this is you're going to take all of the data, the first data set, and I'll link PDF instructions as well, but you punch this into L1, and then you take all of the second data set, and you punch this into L2. Oof, come on, Jolly. There we go. Once you've done that, it's pretty quick to find the t-test and the p-value. So you go to stats, tests. You guys have been there before. And then you're looking for the two-sample t-test. Yeah, two-samp t-test. Once you run that, really you don't want to just mess with any of the settings. Make sure list 1 is L1 and list 2 is L2. Frequency 1 and frequency 2 just leave as 1s. And then make sure the does not equal mu2 is highlighted. So I'll make a note about that. Don't change that setting. And also leave the pooled on no. This is all in the directions, by the way. And then you get these two numbers. You get a t value, which is negative 0.235, and you get a p value, which is 0.816. For this class, this is really all you need. There's other stats classes where you'll actually use the t value in different ways, but we're just going to look at the p value. And then it's very similar to how we've been comparing p-values before. In the problem, they said to test it at a 5% significance level. So we say 0.816 is bigger or smaller than 0.05. Well, it is bigger. So the p is not low. We do not reject the ho. That just means we accept h sub 0, which means there was no significant difference between the two groups. And that's it. That's a basic t-test right there. It's very similar to other tests. You're just comparing the p-value, but yeah, it's used to tell you something different. It's not a test of independence or goodness of fit or something like that. It's just to tell whether or not the two sets are significantly different from each other in terms of their means. Last example, an oil company claims to have developed a fuel that will increase the distance traveled for every liter of fuel. 10 scooters are filled with 1 liter of the normal fuel, and 10 scooters are filled with 1 liter of the new fuel. The distances in kilometers are recorded. So we're going to run a t-test on this. First, we're going to state the null and alternative hypothesis. So the null is that x1 equals x2, which means there is no difference between distance traveled with the original and new fuels. And then the alternative is that there is a difference, that the means are not the same, which means there is a significant difference. Now let's actually find what the t and p values are. Not that we care about the t's, just the p. Remember, punch this into L1, punch this into L2. And then when you run your t-test, so from the 2SAMP t-test, you should get that the t value is negative 2.83, and the p value is 0.00561. Also, I realized I messed up something right here. That's why I paused for a second. So go back to this right here. There's technically 3 different types of t-tests you can do. So instead of checking if these don't equal each other, we're going to actually check if the second one is greater. Because that's kind of the purpose of this problem, is that the company claims that their new fuel will increase the different distance traveled. So that means that we need to check, like they're claiming that the new fuel is better, or it goes further, it's greater than the old one. So when you go in and run your 2-sample t-test, you're actually going to want to highlight something different. So let me here, I'll bring it up. 2-samp t-test. Yeah, so then you're going to want to highlight the greater than mu2 button. That way you should get the right t-values. But don't change anything else. Like leave the frequencies as 1, leave the data pooled as no. Then you should get these t-values right here. They did say in the direction, not the directions on your screen, but in the directions of the book, to test this at a 5% significance level. If it ever doesn't say what significance level to test at, the scientific standard is 5% significance, at least. You have to get at least 5%. So we're going to compare our p-value, which is 0.00561, with 0.05, the 5% significance. So here, the p-value is smaller. Remember, if the p is low, reject the HO. So we reject the null hypothesis, which means we accept H1, which means the company's claim is correct. The new fuel has a larger average distance traveled. Okay, you guys, that's all I got for Chapter 8. Remember, next class we'll be reviewing, and then we'll have the test.